We are now recording. So all I've done here is manipulated this a to the x. If you remember, natural log, the base is e, and some of you guys just kind of remember, well, that cancels that out because they're inverses. That's okay to think of it that way. And this comes down, and so that makes sense. This was a log rule, the power that said I can bring this power to the outside here and multiply it. So all three of those mean the same thing. All right. So if I wanted to write something like 2 to the x, I could actually write 2 to the x as e to the x ln of 2. I mean, it's just another way of writing that. So if I want to find, and notice that there's a variable in the exponent. This is not the power rule where you bring the power down and you subtract 1. Not the same thing. If I want to find this, I don't know how to do it. But I look up here and I say, oh, now I see why she was writing all this junk. I know how to find e to the anything is e to the anything times the derivative of the anything. So let's rewrite this as e to the x ln of a, because again, I know how to take derivatives of e's. So the derivative of this, I guess I'll go to the next line. The derivative of e to the anything, that's why I say you should say it this way, is e to the anything times the derivative of the anything. Okay, so far so good. Now, let me just bring that down. My eyeball, once again, goes right there. So a is what? Constant, which means I could actually bring that out front. And so really all I'm finding the derivative is x. Well, I can do that. So e to the x ln of a times ln of a times 1. If I go back up here and I say, hey, that's that, so I just simply plug this back in and I get a to the x ln of a. You got, I'll say it. Every time I think I'm going to say something funny and it's being recorded, I'll probably get in trouble. So that's some more useful crap for you to memorize. Just shout out right there to you. Okay, so therefore, the derivative of a to the x equals a to the x ln of a. So in other words, you leave the a to the x alone, whatever it is, and then you take the natural log of the base. Remember that a is the base. So if I had just something like, fine, let's go back to 2 to the x, then it would just be 2 to the x ln of 2. And this is on this formula sheet. What I would do is certainly I would print this out and start using it to do your homework. That way you're comfortable with it. You know, you can go down this list and you can figure out where things are on this formula sheet. All right, but what this actually shows is my derivative of e to the x, I can rewrite as e to the x ln of e, because that's what, well, really that one. That's what my definition says. What's ln of e? 1, very good. Did you remember that? And thus, I know my other class didn't answer, and I go, you're going, I don't know, I don't have a calculator. Because this is base e. And so, in other words, this is kind of, oh, well, that's why you can also use this with base e. You can use the same formula when you're finding the derivative of e to the x. So if I write this as the pure definition, meaning that we really don't want to forget chain rules, the derivative of a to the u equals a to the u times ln of a really times du dx. And all this is just your chain rule, saying if there was something more in there, okay, and you had to find the derivative of it, then you have to do it. So if I had find the derivative of 3 to the minus x, well, I guess you can see that definition there. This says, by looking at this, says it would be 3 to the minus x times ln of my base, which is 3, times the derivative of negative x. Okay, so it's kind of those of you that like the not writing the whole u thing down, you're working from the outside and then still continuing working to the inside. So of course this would just be minus 3 to the minus x ln of 3, because that's negative 1. If I had something like 3 to the sine of x, make it where you can still see the formula, I just rewrite that again as 3 to the sine of x, that's that piece. Then I do ln of my base, and then I take the derivative of sine of x, which is cosine of x. So that's that derivative. All right, for those interested parties that love proofs, I'm going to give you a definition, and I'm not going to prove this one, and it is also on the formula sheet, that the derivative of log base a of u equals 1 over u ln of a. And then once again, if there's something inside that, that's all we're saying, is if there's something inside that parentheses, I have to use the chain rule. This is a pure definition. The proof, and I know you're going to all look this up, is in the textbook. Most of you don't even know we have a book, huh? And the only thing is it uses the change of base formula. Man, this class goes by too fast. And I actually have an example using that a student picked out a problem, but I'm not going to do that one today. I'm going to do a different one. So I'll work that one next class. So quickly, let's try to remember some of these log rules. So I want to find dy dx if y equals x squared plus 1 times x plus 3 to the 1/2 power all over x minus 1. Before this class today, most of you would look at that and say, oh my God, that's a quotient rule, that's a product rule, that's a chain rule. And it would be a pretty long and drawn out problem. But you know that we work in the world of magic math, and you can do anything you want. You've learned in algebra if you do it to every single term. If I take natural logs of both sides, so I'm going to have ln of y equals ln of x squared plus 1 times x plus 3 to the 1/2 over x minus 1. There is, if you're, side note, if you have exponents and you want to solve that, what do you do with the exponents? Subtract them. So I remember this. I remember exponents a lot better than logarithms. Well, they're inverses of each other. So if you're dividing, you subtract. If you're multiplying, what do you do with them? You add them. So the log rules, and these are the ones that I say some of you may not remember. The log rule says where I see a product there, I can split up and do a plus, and then where I see a quotient, I can make it a minus. So I'm going to do that. ln of y equals ln of my product, x squared plus 1 times x plus 3 to the 1/2. Uh-oh, hold on. I skipped this. Nah, I didn't skip that step. Never mind. I'm going to split up these logs. X squared plus 1 times x plus 3 to the 1/2 minus, you have to write another log. So this is this log rule. So I've taken a quotient and turned it into a minus. Now I'm going to take a product and turn it into a plus. The only thing you have to remember is when you do that, you have to write logs for each piece. So all I've done is now I've taken this product and I've turned it into pluses. Another log rule I remember is that ln of x squared, what is that, a plus 1? I remember that this 1/2 can come down front. So I have plus 1/2 ln of x plus 3. And I know you're saying, how in the world is this easier than the quotient rule? Wait till you see the answer. Now these are easy to find derivatives. LNs are easy. You write 1 over what's in parentheses times the derivative of what's in parentheses. But notice I'm doing dy dx, so I actually have to write this as the derivative of ln of y is 1 over y dy dx, implicit differentiation. And then each one of these, I'm going to write 1 over what's in parentheses times the derivative of what's in parentheses. Bring that 1/2 out front. This becomes 1 over x plus 3 times 1 times the derivative of x minus 1 over x minus 1 times the derivative of x, which is just 1. So I end up with 1 over y dy dx equals 2x over x squared plus 1 plus 1 over 2x plus 6. I just went ahead and distributed that 2. And now you solve for dy dx, which is pretty easy. I just multiply this whole, all that junk. But I know what y is. It's way up there. So I replace y with that piece. So now when I write this entire answer, tell me if the quotient product chain would have been easier. So my y was x squared plus 1 times x plus 3 to the 1/2 over x minus 1, and then all this leftover junk, 2x x squared plus 1 over 2x plus 6 minus 1 over x minus 1. So that is right there, and then this was substituting back in for my y. And that is your final answer. Okay, so some of these things where I don't figure most of you kind of, I mean, you probably remember now that I said it, that when you had a log and it was a product, you can separate them with pluses. When you have a log that's a quotient, you can separate them with minuses, but you may not have thought to do that. There is a study plan problem, and if you get time, because that's all you have is time, right? If you click on the study plan, look at .8.77 and see if you can work that. A big hint, probably something most of you don't remember, is you're going to have to use the change of base formula. I will work it next class, but Just would be nice to see if some of you can actually go ahead and work it without my help. And again, if you didn't know to use the change of base formula, you probably wouldn't know the answer